Hello, hello. Good. Can't see anybody, but I guess there's people in the room. Welcome to my session on a container toolchain on Microsoft Azure. If you didn't expect to be in this session, I know there's been a couple of back and forward with the schedule. This is what I'm going to talk about. I'm going to try to ask a couple of questions before starting, and please do raise your hands. Move over here, it's a bit easier. Cool. Who in here would say about themselves that they are not a developer? Interesting. Kind of what I expected. First time for me talking in front of a 100% developer audience, because I am not a developer. And so that's going to make this talk very interesting. The idea behind this talk was, or why I pitched this talk, is so I'm a consultant. I help people move their applications from A to B, A usually on-prem, B usually the Microsoft cloud. And there's a lot of, oh, this is easy, we can just move this over, it's just lift and shift, it's a container, because we've already containerized our application. So we're just going to lift and shift and it's done. Pretty easy. It's usually not the case. I know a lot of developers, and I am going to have some very strong opinions today, by the way. A lot of developers are a bit ignorant sometimes about the deployment side of things, which is in some environments fine, in other environments not so much. So today is going to be, how do we get our application from somebody's laptop into production? And the main focus is going to be doing this on Windows, because my background is Microsoft. I've used Linux in the past, but yeah, my focus is Microsoft. And this is something that a lot of people say when they hear about putting Windows into a highly flexible, highly dynamic environment. It's Windows, it just doesn't work. If anybody's been to one of the container sessions yesterday, somebody already asked, why would I use a Windows container even if it's only 200 megabytes in size? It's way too big. And yeah, usually your Windows containers nowadays are around 10 gigabytes in size. So somebody already complains about 200 megabytes. That's saying a lot. Just a quick agenda overview. Quickly on Windows containers, where they're at the moment, where is Microsoft currently at with their container story, specifically with Nanoserver. If you haven't heard about Nanoserver, this is going to be a quick summary of that. And then how do we actually deploy containers, mainly Windows containers, onto Microsoft Azure, what solutions are out there, and what would a pipeline to build and deploy a Windows container actually look like. And then a very critical view on, are Windows containers actually ready, or is Nanoserver ready for prime time? All right, Windows containers. They are pretty new to the Microsoft ecosystem. They really just gone into GA with Windows Server 2016, so fairly recently. And initially, it was really just Windows Server Core. And Windows Server Core, if you don't know, Windows Server Core is a full-blown Windows Server operating system, or just without the UI. You get a little shell, but that's it. Problem with Windows Server Core is that the vanilla size of that is still 4.5 gigabytes. And deploying 4.5 gigabyte size containers is not very cloudy, yeah, if that makes sense. Especially if you need to quickly spin them up and tear them down and spin them up again, or they have to go and self-heal themselves. And I'm actually going to show you that in a demo later on. I'm actually going to skip that demo because it just takes way too long. And that's why Microsoft then went and completely redesigned Windows Server, essentially, and came out with Windows Nanoserver. And Windows Nanoserver is really an OS which was supposed to be For infrastructure workloads like your web servers, your file servers, your Hyper-V servers, but nobody picked that up, nobody wanted that. People wanted to use Nanoserver for containers. Plus, who cares about infrastructure, right? So Microsoft said, okay, we're just going to focus Nanoserver on containers and strip pretty much everything out. So since Microsoft Windows Server 1803, which was, I think, in February, not in March, the container image, the decompressed container image for Windows Nanoserver is 236 megabytes. And with 236 megabytes, you do get your functioning Windows Server. Problem with that is there's pretty much nothing in it. So in order to get to that point, Microsoft removed pretty much everything that they thought nobody needed. So it's bring your own components. Yeah. So if you need .NET Core for your application, then you have to go and either bring it yourself or you install it. So it's either inside of your application already or you just download it on demand. So you usually package it in. Same with WMI or PowerShell. So it's a Windows server that doesn't have PowerShell because there's no .NET, so you can't have PowerShell. But another thing, Windows Nanoserver doesn't run .NET Framework. So it only runs .NET Core. So if your application is not capable of being recompiled into .NET Core for whatever reason, then you can't use Nanoserver, so you have to go back to Windows Server Core. And then, in my opinion, you should really not be using containers for that application. Another thing, especially people that have been using Windows for quite a while or have ever spoken, or your application needs to have downtime over the weekend because we have to patch our machines. Yeah. And that's a thing of the past because you can't patch Nanoserver anymore. So there's no patching, there's no WSUS for Nanoserver because it's a container. So what do? You pull the latest version of that container image and then recycle your containers. Make sense? That's just a quick recap of Windows Nanoserver. And please, if you do have questions, just shout out, because I can't see anybody except for the first row. So if you do have a question, please just shout. So how do we manage containers on Microsoft Azure? And I'm really only going to focus on Microsoft Azure because as soon as I start talking multiple clouds, it just gets way too complicated. Plus, in my opinion, multiple clouds in one solution is just not a thing, just not viable. So focus on one cloud. So Microsoft started off with something called Azure Container Services, which really was a platform, or actually it is a platform to host orchestrators on. It was semi-managed, I say unmanaged, but it was semi-managed. You pretty much pick your orchestrator of choice. We quickly found out pretty much everybody picked Kubernetes, which is why the last point. But on ACS, you could just go and deploy your container, your Kubernetes container orchestrator onto that platform, and then use that to deploy your containers against. Something that Microsoft then also did and released was Azure Container Instances, something that before they did it, nobody else, as far as I know, I think Google had something similar, did, where you could just go and tell that service, here's my image, please go and run that image. And you get one. AWS has something, I think they call it Fargate, where you just point them at an image and they spin one container up of that image. It's pretty nice feature for build agents, where all you need is that one build agent, you bring it up, it's there for a couple of minutes, and then they spin it back down. Plus they also charge you by the second for that, I think. And because everybody everywhere said, well, we really want to use Kubernetes, or we think Kubernetes is the best orchestrator for containers for whatever reason, Microsoft went and said, okay, well, we're going to give you a managed Kubernetes environment then. And that's something they now call AKS, Azure Kubernetes Services. And that's the fully managed Kubernetes environment, where up here, they go and deploy it for you on ACS. But then you have to go and patch your nodes, you have to go and update Kubernetes yourself, you have to take care of all of that. Plus you get charged for all compute up here, done here on AKS. What they do is it's fully managed, so they patch everything. Plus you don't get charged for the actual management layer. So the actual management layer on AKS is completely free. You only pay for the nodes that you spin up, which is pretty nice, because why would I want to pay for the actual management platform? All right, that's just a quick recap on what is Windows Nanoserver, what solutions are out there on Microsoft Azure for containers. So something that I usually start off with is the path into production. And traditionally, you might have seen something like that. It doesn't even have to be Azure, it could be on-prem. You've got your load balancer, a couple of virtual machines, and somebody then deploys your binary onto those virtual machines, usually manually. Maybe over here somewhere you've already got your build server with Jenkins or TeamCity or whatever. Or you just build in Visual Studio, drop it into a file share, and then somebody picks it up over the weekend, deploys, copies it onto IIS, for example. Not very reliable. Yeah, one of the machines goes down, suddenly you only have two in your load balancer. That one doesn't even work, so you only really have one. So not a great solution to go into production. And then people said, well, but now we've got containers. Now we just create an image. Everything's contained in that tiny image that we've got. So deploying that is really easy, because all we have to do is tell our orchestrator, Kubernetes, there you go. So what a lot of people, or what a lot of vendors, pretty much every vendor out there tells you then in their blog articles and their how-tos and tutorials is, well, in Visual Studio, yeah, you build your solution. If you're a C# guy or .NET in general or anywhere, you build your solution and then you right-click deploy onto Azure. Yeah, something that also a lot of people do, where there is no path into production. It's from my laptop over into prod. And then even though it's not supposed to be, it works on my machine, yeah, because now we have containers and they are supposed to abstract the machine away. Suddenly now we do have a dependency on somebody's laptop again. So that's something that someone at Microsoft, one of their cloud developer advocates, has coined, friends don't let friends right-click deploy. It's just not a thing. You can, maybe if you want to do that in your dev environment and you just quickly want to deploy that image, that's fine. But even then, because it's a container, even on Windows, you'd install Docker on Windows, you get your Kubernetes on Windows already locally installed Kubernetes, just with a tick of a box. So you don't have to deploy those containers to the cloud anyways to dev them out. So you just go and do that locally on your machine. As you should, because that's now your container unit test. That's rather what a deployment pipeline, a build and deployment pipeline into production roughly should look like. We all commit to code. I guess that's fairly common. Does anybody shake their heads? No? Cool. I go to a lot of conferences where there's like, how do you use Git? Yeah. It's still a fairly common thing, unfortunately. But if you want to do any of this, you need that. Yeah, we all commit to code. And it doesn't have to be Git. If you're TFEC or Subversion or Mercurial or whatever, shop, doesn't matter as long as you do source control. It's just that everybody integrates into Git. And then on Azure, there's something called VSTS, Visual Studio Team Services. Anybody not heard of VSTS before? Couple of hands, okay. VSTS, even though it says VS, Visual Studio Team Services, has nothing to do with Visual Studio. Yeah, that's just really important to understand. You don't need Visual Studio for VSTS. Really has nothing to do with it. Visual Studio integrates quite well into VSTS, but that's it. In my opinion, they should just get rid of that VS in front of VSTS and just call it something else. Because that's really something a lot of customers of mine tell me, but we're not a .NET shop. Yeah, why would we use that if we're a .NET? If we're not a .NET shop? Because you can build Java, you can build Go, you can build whatever you want on there. Has nothing to do with Visual Studio. Okay, I think I've said that enough now. But what it is it's a suite of components. So it comes with an agile backlog, it comes with a marketplace for extensions, it comes with a build component, it comes with a release management component, it has its own NuGet feed. If you are using NuGet, then it has its own artifact repository. It comes with its own test automation frameworks, so you can, visualization, where you can just run your test frameworks inside of build, and that gets visualized quite nicely in VSTS. Plus, it integrates into pretty much whatever you want, which is another thing. Just because I'm running it inside of Azure and VSTS itself is hosted on Azure, and it integrates quite nicely into Azure, I do have customers that use VSTS to build code that then through VSTS gets deployed onto other cloud platforms. One of the reasons why is if you're a small shop, up to 5 developers, VSTS is completely free. Get that for free. Fully blown CI/CD environment, hosted, no servers, yeah, completely PaaS, essentially, with hosted build agents for Windows and Linux. And does anybody need to build on Mac OS? Is anybody doing that? One hand? Cool. 2 hands? Usually means you need to have physical macOS machines. VSTS gives you hosted macOS build agents. So just get rid of those physical machines. You can do that for free on VSTS. Cool. So from Git, we go into VSTS. That would trigger a build pipeline, and I'm going to show that in the demo in a couple of minutes. And then on VSTS build, in our build pipeline, we would obviously go and use that Docker file and build that Docker image. If we wanted to, we could test that Docker image. Not easy to test Docker images, to be completely honest. I think that's still a gap in Docker. If anybody knows how to properly test Docker images, please let me know. Usually what I do is I spin them up, run something against the endpoint and see if it works. then go and use something called the Azure Container Registry, which is just like your Docker Hub or any other Docker container registry, just hosted on Azure, securely hosted on Azure. You can use airbag and all of that to make sure that only certain processes or people can access those containers, sorry, images. Because we've done that, that triggers off a release management pipeline. So Microsoft calls it build and release. That's your CI, and that's your CD. And over here, you can do CD, continuous delivery, and you can do continuous deployment, obviously. Over here, we will then go and deploy to our Azure Kubernetes. And there's a big caveat on this one at the moment. So AKS is still not generally available. Yeah, so it's still in preview. It's going to go GA fairly soon. That's my understanding. Which means that right now I'm using a CS, Container Services, the semi-managed version of Kubernetes on Azure. One of the other reasons is because I want to deploy Windows pool, and AKS at the moment in preview doesn't support Windows nodes. And I'm going to pick that one up in my summary later on. So this pipeline then deploys to ACS, which runs Kubernetes in my case. And then I've got a test namespace on Kubernetes and a prod namespace on Kubernetes, which represents my test and prod environment, obviously. Depending on who you are and how much separation you want, you would probably have multiple of these without going into Kubernetes too much. If you want to do any sort of load testing, for example, on test, and you separate your test environment and prod environment through namespaces, then it's obviously all running on the same hardware. It's using the same underlying compute, and you don't want to do load testing on test and then impact your prod environment. So just be aware of that. And with that, if there's no questions, let's have a look at the demo. There we go. No. All right. So my use case for what I want to go and deploy is Grafana. Grafana is a metrics visualization application. It's free, it's open source, it's written in Go. And because it's written in Go, I can run it on Windows. But what it does, it just represents an application which is exposed via a website and that I want to go and deploy onto a container. And if anybody's not familiar with Docker, I'm using the latest Nanoserver image up here. And then I do a couple of things. I install Grafana and then deploy that. Over here in VSTS, I've got my build pipeline, my build definition, which is fairly simple. If the internet lets me go there. Yeah, good. So right now, VSTS doesn't do pipelines as code. So that's one of their drawbacks. Right now, at least, they have it in preview. But it's still fairly rough preview in my opinion. It works, it's just a bit rough. So whatever you do in VSTS, it goes via the UI. And what I do is I do a couple of steps. I push the Nanoserver Grafana image over, or I build it, and then I push it over to ACR as a container registry. And then do that again and push it to Docker Hub. So if anybody's interested in that image, they can just go to Docker Hub and get the Grafana image from there. That's just something so that if anybody was interested. And then I'll replace some tokens in my Kubernetes YAML file, which I can show you here. So the Grafana application itself consists of a front end and a back end. And because Grafana only supports Postgres as a database, and because ACS and both ACS and AKS don't support hybrid pools at the moment, that's mainly because of the Kubernetes versions that they use right now. I had to go and put Postgres onto Windows Server Core, and just spinning up that Windows Server Core Postgres database takes around 12 minutes, which is not very container friendly, which is why I'm not going to show you the from zero to a working Grafana environment, but I'm going to show you some updates. So this build ID up here, because it's not a good practice to use latest in our image references, I use the actual build ID. Yeah, I do tag my images with latest, but also with the actual build ID coming out of VSTS. And the VSTS build step then replaces the build ID with the actual build ID. And that's just a bit of PowerShell. And the actual artifact of this build pipeline is then the Grafana YAML file that then gets published, and that then triggers off a release pipeline. And in VSTS, I've configured my release definition to deploy into two environments, test and prod. And a nice thing in VSTS is that it's fairly simple to see in which state my environments are currently in. So if I wanted to know which version is currently running in prod, I could go back and see that release number 2 is currently in prod. It's the last version that was deployed into prod. And over here on Kubernetes, I can see my test and my prod namespace, which represents my environments in VSTS. And in my test namespace, I already have the Grafana DB and the Grafana app deployments, where the Grafana DB, because Postgres and supermassive fat Windows Server Core, I only deployed one of them. So the database layer is not very highly available, but the actual front end consists of 5 pods, or 5 container images, 5 containers. And they're all running. Nothing out of the ordinary here. And they're exposed via a service that I can go and browse to. So currently we can see that there's the Azure monitor installed, plus there's the drop-down menu on the left, and what I am going to show in demo is the flow through code through the pipelines to update the actual database, because a couple of days ago, Grafana 5.1.3 was released. So what I want to do is update my Docker file. And just update all references, plus I'm gonna install this update again. And there's one more. Good. All right, all I have to do is then commit those changes and push them over to VSTS. Actually, I'm using GitHub as my source code repository, and my VSTS pipeline is hooked up into the GitHub repository. So even though I'm using VSTS, I am not forced to use the VSTS code repository. By the way, if I wanted to, VSTS, again, VSTS is free. VSTS also gives you unlimited private Git repositories, where on GitHub, I think you have to pay like $7 a month. All right, so that's currently in progress. And that's going to take around 4 to 5 minutes to then push that over to the release pipeline. I'm using a hosted agent, so it doesn't cost me anything. I don't have to go and build my agent. I don't have to go and patch my agent. Those agents already come with all tools that I require. And only if I, for whatever reason, had to use a version of a tool that Microsoft doesn't install on those build agents, then I could either go and install that tool during my build, which is obviously not the nicest way of doing it, or I could just go and create my own build agent. So that's currently building. And while that is building, I'm just going to quickly jump back to, not that, the presentation. Also not that. Let's try that again. There we go. A quick summary on Windows containers and using them currently in production, maybe even. So Windows Nanoserver itself, I would just not really bother using Windows Server Core as a container OS at the moment, because it's just way too big. With Windows Nanoserver, the issue is that it only runs .NET Core. And even though with some applications you just go into Visual Studio and run, recompile it in .NET Core, and they work, with most applications that's just not going to be the case, because you rely on third-party libraries, or you use something that just doesn't exist in .NET Core. So you might need to actually go and redevelop your application, which is obviously not a quick thing to do. But why would I use a Nanoserver image? Or why would I use Windows? Because C# and Visual Studio is already well known to .NET developers. So all of that, and then working on Windows, feels very native to developers. Thing is, and that goes back to what that person yesterday said, compared to Linux, it's still very fat, even though they've already reduced it to 280 something megabytes. A lot of people then tell me, yeah, have you heard about Alpine Linux? Yeah, so Alpine is 3.97 megabytes in size. Granted, you don't even get bash in those 3.97 megabytes, but in 286 you don't even get PowerShell. So, and then if you want to use PowerShell, you need .NET Core, and then you end up with something like 600, 700 megabytes in size. The biggest issue that I have with why would I use or why would I not use Nanoserver as a container OS on any cloud is because most tools are just Linux first. Yeah, they really don't care about the OS specifically, but because those people want to develop on Linux, they start supporting Linux first. Even Microsoft releasing ACS and AKS, they support Linux first. And I'm going to get to that in that my second part of my demo, where a lot of things are just not ready for Windows yet. And most of those things are things that you require to go into production, like monitoring and alerting. What is actually happening on my container? Which, and now I'm going to step on some people's toes a bit, is something that a lot of developers just don't care about. Yeah, because it happens further down the pipeline. And my point is, or my argument is, everybody should care about that. Yeah, because at some point, somebody makes a decision, which OS are we going to use? And saying, well, but we always have used Windows, so we're just going to continue sticking to Windows, is just not a good argument. You have to see the whole picture. So I then usually go and say, using Nanoserver is really not a need. You don't need to use Nanoserver. If you're developing in Java, then yeah, you can run that on Nanoserver. But you probably are going to run that on Linux. If you're running Go or writing Go, then you're probably not even thinking about Windows initially. You're running that on Linux. If you're a .NET shop, then previous point, you have to run .NET Core, and .NET Core runs on Linux. And if you don't care about the OS, then other points take precedence, like we need to run in production, we need to monitor our stuff, so we're just going to do it on Linux. And then at some point the question is, why do we even need Nanoserver? It's something that a lot of people do have very heated discussions about. What is the future of Windows OS, especially when we talk about containers? And the funny thing is that I think that I'm, at least in all those sessions that I've been to during this week, I think I'm the first one who's actually ever mentioned the underlying OS, which I find very interesting, because usually it's completely the other way around, where everybody argues about which OS are we going to use, and no, we have to use Windows. All right, let's switch back. So our build ran, and let's refresh that. And our release 30 also ran. So it's now in test. And another thing, I've set up a VSTS to Slack integration. So strictly speaking, I don't even have to monitor VSTS, because Slack is going to tell me that Grafana has been successfully deployed into test. And then in here, eventually, yeah. Internet connection feels like the one at home. Really slow. All right, so test succeeded, and the containers, as we can see, they have also now been cycled. They're all green. They're around 2 minutes old. And let's refresh the Grafana endpoint. Let's not touch that. Oh, and let's let that load for a second. Ah, there we go. Cool. You just have to go and do something else, and then it works. Cool. So Grafana has just been updated. There was no downtime to the actual update because containers, and we have rolling updates configured on Kubernetes. So our not this one, our test deployment worked. So in VSTS, I can now go and say here in prod, in here, that our release 30 can now be approved to go into prod. All right. So one of the things that I mentioned about going into production is you have to go and monitor your applications. And to my point that I made a few minutes ago, there are quite a few. Yeah, there's a lot of tools out there. Microsoft has their own called OMS, Operations Management Suite, and they have a container monitoring solution. That comes out of the box. You can install that and point that at your as another deployment at your Kubernetes cluster. Problem is, and we can see that over there, we see exactly one container node, but we go back to actual Kubernetes, there's 3. And reason for that is because our master is Linux and the other 2 are Windows. So the built-in solution from Microsoft to monitor containers doesn't support Windows yet, which is probably partially because Kubernetes still hasn't caught up. My understanding is that with version 1.9 point something, Windows support is going to get better, but it's not there yet. So monitoring container nodes is at the moment a bit flaky. Where the answer to that usually is where you can go and install the actual OMS agent into your container. Back to what that person yesterday said, 200 megabytes is already super big. Adding something on top of my application to monitor my application means I have now have multiple applications running in my container, which usually is not a good practice. And I have to go and install something. Where with Linux and other solutions, that just happens from my container cluster. Which also means that because my Grafana images are running on those Windows containers, I can't see any logs coming out of my Grafana containers because for OMS, they just don't exist. And the same is true for solutions like Sysdig, which is a fairly widely spread or well-known monitoring solution. It's a SaaS, where again you just go and install the connection between your cluster and Sysdig via a Kubernetes deployment. Very lightweight, doesn't really do much except for forwarding metrics. But even they as well don't show you anything about Windows. Right, that's working. All right, let's go back to this one. And with that, I've got 4 minutes left. I want to open up to questions, if there's any, that I can't see any questions. Great. Cool. I could just pick up what the speaker in another room said. Is that a cultural thing that you don't ask questions? Yeah? Cool. Doesn't matter. I'm still going to be here for the rest of the day. If you do feel you have questions, please come and talk to me. I know it's not super natural for developers to talk about infrastructure and infrastructure deployments, but for the next 3 minutes, I can go on and rant about that the job of a developer, in my opinion, doesn't exist anymore. Just like the job of a system administrator doesn't exist anymore. I could say that we're all now DevOps, which isn't true because DevOps is not a job. But everybody should at least know something about what the other side is doing. Yeah, and already coming to that talk here either means I tricked you with that talk description into coming here, or you were actually interested in how to deploy containers, which would be my preference. And that's the way to go. We all need to know what the traditionally other side were doing. Yeah, I've got Visual Studio on my machine. I write Golang, I write Python, I don't write Java. But I now start writing applications because customers expect that from me. And I expect developers at customers to be able to build pipelines and deploy their applications. Because if they go and write an application, even if it's a container, especially if it's a container, and that goes into production, they have to go and maintain that and go and work on that. Yeah, you were first. Yeah. All right. Yeah. So the pipeline that I've shown you and monitoring and all of that surrounding. So the question was, not sure if the camera is going to pick that up. How reasonable is it to always build all of that infrastructure? Correct? Yeah, cool. For a POC, no. Yeah, for a POC, no, but that POC is at some point going to go live. Yeah, if you go and want to, it really depends on what you want to POC. Yeah, if you want to POC out, can my application actually run in a container? Yeah, is it possible to containerize this application? Then do it on your machine. Yeah, spin it up on your machine, use Docker, use Kubernetes on your machine, Minikube and all of that exist to actually do that, to dev on your machine. But then taking that knowledge and again putting it onto a VM doesn't make sense. So if you already decided, yeah, I want to go and check out if I can do it on a container, then take that knowledge on and actually deploy containers into production. So I would say for a quick POC, no, overkill. but as soon as this POC has been decided to go anywhere, which most POCs usually do, then yeah, you need at least that. Granularity, yeah. So are you asking who's going to look after all of that? Are you asking who's going to look after all of that? Who's going to maintain all of that? Yeah, whoever deploys it. Yeah. um, yeah, you split everything up. Yeah, you split your front end, your mid tier, your back end up into your own containers. Even though databases, I wouldn't really put them into container. That was just for the sake of the demo. And yeah, then all of these surroundings, whoever deploys that needs to go and look after it. Let's take that offline for after the session. There was another question over here. Yes. They're gonna do it. Yeah. Yeah. So I think the next iteration is already going down to like 200. But eventually, yeah, there's a button. Yeah. Well, yeah, but do you need that? Yeah. Are you Netflix? Do you need to spin 1,000 containers up in 5 seconds? Yeah. Okay. Cool. Yeah. But do you really need to use Alpine? That's my argument. Using Alpine is fine, but when people come and tell me, well, 200 megabytes is still way too big. It takes 5 seconds to spin it up. Really, 5 seconds. Yeah, like what's your use case? Yeah, you always work towards a use case. All right, I do have a bit of advertising. I do have a Pluralsight course up on this topic. So if anybody's interested in seeing a bit more demos and hearing a bit more about how to actually do this, I do have a Pluralsight course on that. And if you are wondering who I am, then I'm that guy. I'm not the guy on the speaker website anymore. So that picture is around 10 years old. I really need a new picture for my speaker submissions. But yeah, I'm that guy. I have my own company down in Melbourne, in Australia. So came all the way from Australia. Even though I'm not Australian, if you can't tell, this is not how Australians sound. So I'm German Scottish, but we moved to Australia about 5 years ago. That's my Twitter handle. Please go and ask me any questions on Twitter. It's usually the best way to reach me. Also, I'm a Microsoft MVP for Azure, so if there's anything on Azure in general that you need help with, happy to help. And there's my blog that does it's pretty much my own wiki, my own knowledge base. Whenever I go and do something that I think I need at some point again, I put that onto my blog. All right, with that, I think my time's up. I have no idea how much my time is up, but thank you very much. I hope everybody learned at least one thing, and enjoy the rest of the conference. Thank you.